Hi, this is CAD CAM Lessons channel, and in this video I will show you some basic operations for creating 3D solids in FreeCAD. FreeCAD is a completely free 3D CAD system where we can create our own 3D models. For example, for 3D printing, we can freely use FreeCAD. We can use this system for both hobby projects and commercial projects where we can earn money. FreeCAD is open source software, meaning it is developed by a community of users. This makes it open software and anyone can freely use this system. We can install FreeCAD on any number of computers. FreeCAD does not require internet access. Everything we do is done locally on the computer, so we don't work in the cloud. In many cases, this can be a very convenient solution. Now I'll show you some simple and example operations for creating 3D solids in FreeCAD. If you haven't subscribed to this channel yet, please subscribe, and if you want to support this channel, you will find information in the description of this video on how to do that. And now, let's move on to FreeCAD. FreeCAD is a modular system. Modules in FreeCAD are called workbenches, and you may often see the abbreviation WB. We have several different workbenches where we can create projects. When it comes to creating 3D models, we will most often do it in the Part Design workbench. There is also a Part workbench where we can create 3D models, but it is the Part Design workbench that is primarily used for creating parts. The work methodology used in this module is similar to other 3D CAD systems. In this case, in this module, we work on features and parameters, meaning we create a parametric model. This model is usually created in such a way that we first create a 2D sketch and then use 3D solid creation operations based on the 2D sketch to create a 3D solid. To start a new project in the Part Design module, we select the Part Design module and click the New button, or simply click here on the parametric part. We have a new project started in the Part Design module. We will proceed to create a new project and learn a few basic operations for creating 3D solids in this system. However, before we do that, make sure you have the Blender navigation style selected, as this will affect how we navigate in this system. Another thing that might be useful is if you don't have the icons like I do, click the right mouse button and check if you have all these options enabled. If you don't have some option enabled, just enable it, and if you want to change the position of the icons, simply drag the icon bar to the desired location. We will start creating a new part. We have the operation tree. As you can see, we already have a body created, and a body represents a single solid. In one project we can have several body type elements, but in one body type element there must be one single solid, and they cannot be two separate solids. We will start the creation of a solid by creating a sketch. To create a sketch, click the Create Sketch icon. We have the basic coordinate planes to choose from: the XY plane, the XZ plane, and the YZ plane. Let's choose the XY plane. Notice what happened here. We have been switched to the Sketcher module. The commands have changed. The Sketcher module is closely linked to the Part Design module because it is in the Sketcher module that we create sketches, which we can then use in the Part Design module for 3D solid creation operations. We will start here by creating a rectangle. First, I will draw any rectangle. I select the creation of a rectangle, and when it comes to drawing a rectangle, we need to define two vertices of that rectangle. When drawing the rectangle, we can immediately specify the dimensions of that rectangle, but I haven't done that yet. I have drawn a rectangle here, and the command to draw a rectangle is still active. I simply point to two vertices of the rectangle, and I have drawn a rectangle. Now I will draw another rectangle. I click here, and I will specify the dimensions of this rectangle. For example, 50 by 30 millimeters, so I enter the dimension, hit enter, enter the second dimension, and hit enter. I have drawn a rectangle, and this rectangle now has specific dimensions, 50 by 30 millimeters. The rectangle drawing command is still active. If we want to finish this command, we can select another command, or we can right-click to finish this command. We have three rectangles here, and this rectangle has specified dimensions. I cannot change the dimensions of this rectangle freely, but I can freely change the position of this rectangle. As for these rectangles, I can change both their dimensions and positions. To change the dimensions, I grab the corner of the rectangle and drag it, and the dimension of the rectangle changes. To change the position, I grab the line of the rectangle, and I can freely change its position. In this case, we can only change the position. The dimensions are already strictly defined. However, regarding this sketch is not correct because, as I mentioned at the beginning, when creating a body type part, it must be one single solid, and based on this sketch we would create 3 solids because these sketches are not connected. Therefore, we don't do such things in FreeCAD. But another thing is that we try to create a sketch in such a way that the sketch is fully constrained. In this case, we have 10 degrees of freedom. This sketch is not constrained. The geometries are not yet fully defined. We will do that shortly so that it is fully defined. However, I will quickly return to these 2 rectangles. If we create some geometry and do not define the dimensions while drawing the geometry, we can also do this at this stage. All we need to do is select the geometry we want to dimension and choose the dimensioning command. Here we have the dimension command, which will automatically select the dimension we want to apply. In this case, I selected this line, choose the dimension command, and here I can simply specify the length of this line and enter, for example, 40 millimeters. The dimensioning command is still active, so now I select this line and here enter 20 millimeters. This rectangle has now been dimensioned. I right-click to cancel this command, and in this way we can add dimensions to the geometry if we didn't add those dimensions while drawing the geometry. Here, if you expand this command, we also have single dimensions. We can select a specific dimension we want to apply, but usually this command automatically selects the correct dimension we want to apply to the geometry. And so, we have a bit too much of this geometry here. If we create some geometry and want to delete it, we simply select the geometry. We can do this by selecting a selection window. I press the left mouse button and drag the selection window over the geometry I want to delete. Then I press the delete key. We can also select geometry one by one that we want to delete, and in the Sketcher module we simply do this by clicking the left mouse button on the geometry we want to select. We just left click and that geometry will be selected. And if we want to deselect the geometry, we just click somewhere outside of the geometries and those geometries will be deselected. I will select the geometry of the rectangle and press delete to remove this rectangle. We have this rectangle and here we still have 2 degrees of freedom. These degrees of freedom come from the fact that the position of this rectangle is not defined. We can define the position of this rectangle along the x and y axis. Hence we have these 2 degrees of freedom. We can do this with dimensions or with constraints. The position of the geometry is defined relative to the origin of the coordinate system or relative to another geometry. In this case we don't have another geometry, so we can define the position of this rectangle relative to the origin of the coordinate system. We can do this, for example, by selecting this point, and adding here a dimension along the x-axis, for example 10 millimeters. See that there is now only 1 degree of freedom left. Now I select this point, and here in the y-axis I will enter, for example, 5 millimeters. We have information that the sketch is fully constrained and the geometry of the sketch has changed color to green. This means that the sketch is fully defined and we cannot freely change either the dimensions of this sketch or the position of this sketch. This is what we strive for when creating 2D sketches in 3D CAD systems. Another way to define the position of the geometry is to use constraints. I will select this dimension, press delete, select this dimension, and also press delete to remove these dimensions. We can define the position of this rectangle, for example, by linking these 2 points together. To do this, we will use a coincident constraint, meaning we select these 2 points and choose the coincident constraint. Now this constraint has caused these 2 points to be linked together, and thanks to this, we also have a fully constrained sketch and a fully defined position of this sketch. Now I will create another geometry. We will create a circle, select the circle drawing and draw a circle inside the rectangle. I clicked with the left mouse button to define the position of the center point of this circle, and now I can define the diameter of this circle. I enter 10 millimeters and press enter. We have a circle with a diameter of 10 millimeters. Now I will draw a second circle roughly here. I click the left mouse button and draw a circle of any diameter. Now I will right-click to cancel the circle drawing command, and here we have two circles, one circle with a diameter of 10 millimeters, and I cannot change the diameter of this circle, but I can change the position of this circle. I have a second circle whose diameter and position I can change. I would like these two circles to have the same diameter, and to do this, I will use an equality constraint. I select this circle, and choose the equality constraint. Now these two circles are equal to each other, and even though this circle is not dimensioned, I can no longer freely change the diameter of this circle. I can change the position of this circle, but I cannot freely change the diameter of this circle. Now, if I change the diameter of this circle, to do this, I double-click the left mouse button on the dimension and enter a new value, for example 15 millimeters, then press enter. The diameter of this circle has also automatically changed. Constraints have a huge advantage because if there were more of these circles, I would create another circle. Okay, and I will also link this circle to this circle. Now I change the diameter of this circle to 10 millimeters. The diameters of the other circles have also been changed. In such a situation, where we have many identical geometries in a sketch, and these geometries have the same dimensions, it is a good solution to use constraints instead of specifying the dimensions of each geometry separately. As in this case, we linked this geometry with an equality constraint. Now, if I need to change the dimension of those circles, I simply change the dimension of one circle, and the dimensions of the other circles change automatically. This can save a lot of time when creating 2D sketches. Now we have three circles here. I will remove one of them. I select this circle, press delete, and we have two circles. I would like to place these circles in such a way that they lie on a line passing through the center of the rectangle and are symmetrically arranged along the line passing through the center of the rectangle. Let's create auxiliary geometry, because when it comes to sketching, we have main geometry in the sketch, which is the geometry from which we create a 3D solid, and we can also use construction geometries in the sketch, which are only auxiliary geometries and do not participate in the further process of creating the 3D solid. When we create a 3D solid based on the 2D sketch, the construction geometries will not be considered. They are just auxiliary geometries in the sketch. Such construction geometries are very useful because they allow us to create such auxiliary geometries against which we can define the dimensions and positions of other geometries. Now, I will create two lines. I select the line drawing, and I would like to draw a line whose first point will be linked to this line, and the second point will be linked to this line. We can do this automatically by using automatic constraints. Make sure you have the automatic constraint option enabled. Now when you hover the cursor over this line is highlighted. By clicking with the left mouse button, the first point will be linked to this line. Then, when you hover the cursor over this line and click with the left mouse button, this point will be linked to this line. A symmetry constraint was automatically applied, which placed this point in the middle of this line. Now we will create the second construction line. Here we will not use automatic constraints, we will add constraints manually. Therefore, draw this line roughly like this. Right-click to cancel the line drawing command. Now, this line is not linked to the rectangle geometry at all. This line is already linked to this rectangle. Here, automatic constraints have been applied. But regarding this line is not linked to the rectangle, and we can freely change the position and length of this line. Notice that these two geometries are selected, so I click the left mouse button somewhere outside geometry to deselect them. Now we will apply constraints. As for the constraint that will place this point on this line, it is a coincident constraint. We select this point, select the line, and choose the coincident constraint. Now, this point is linked to this line, but we can freely change the position of this point along this line. Now I press Ctrl Z to undo this constraint, and we can apply a symmetry constraint between these 2 points. We select this point, and select this point, and we choose the symmetry constraint. Now, this point has been symmetrically placed between these 2 points, and now this constraint has made that this point is symmetrically placed between these 2 points, so it has also been automatically placed on this line, and we can no longer change the position of this point, we can only change the length of this line, and here we can also apply a symmetry constraint between these points, or we can select this point, this line, and here we can select a coincidence constraint, and now this geometry is fully constrained and placed in a way that it is in the middle of this rectangle. This geometry is in the middle of this rectangle on this axis, and this geometry is in the middle of this rectangle on this axis. And so, at this point, these geometries are the main sketch geometries and will participate in the creation of a 3D solid based on this sketch. In order for these geometries to be only auxiliary geometries, we need to change this geometry to construction geometry, and to do this we select these 2 geometries and choose the option to switch geometry to construction geometry. And now these geometries have changed color, changed their shape, and this means that these geometries are auxiliary geometry of the sketch. And now we constrain the circles to this construction geometry. First, let's do it so that these circles are placed symmetrically to this line. To do this, we select the center of this circle, select the center of this circle, and select this line, and choose the symmetry constraint. And now these circles are already placed symmetrically to this line. As I change the position of one circle, the position of the second circle is adjusted in such a way that it is placed symmetrically to the line passing through the center of the rectangle. And now let's add a specific distance between the centers of these circles. I select the centers of 2 circles and choose dimensioning. And here is the distance between the centers of the circles. Let's enter 25 millimeters. I press enter. OK. I right-click to cancel dimensioning. And now I can change the position of these circles, but only in such a way that they can move up and down. Here the distance between the centers of the circles is already defined and we cannot freely change it, but we can change the position of the circles up and down. And now I would like these circles to be placed in the center of this rectangle, that is, the centers of the circles lie on this line. As you can guess, we can do this using the coincidence constraint. Select the center of one circle, select this line and choose the coincidence constraint. And now the sketch is fully constrained. The position and dimensions of the sketch are already fully defined, and based on such a sketch we can create a 3D solid. To do this, we close the sketch. Here we have returned to the Part Design module, and such a basic operation of creating 3D solids in 3D CAD systems is the operation of extruding a sketch. In FreeCAD it is the pad operation. Select this operation. Here we define the length of the extrusion. In this case we define the height of this solid. When it comes to the values in this field, we can change these values in such a way that we enter a specific value here from the keyboard, or rotate the mouse wheel, and in this way we can also change the value of the extrusion. Here is the extrusion length, enter 10 millimeters. When you left click next to this field, the preview will be updated, and we click OK to confirm it. And this is how we created the first 3D solid. Here, when it comes to navigation, I use the space mouse from 3D Connection, but it is not an essential device. And when it comes to mouse navigation, when you press the mouse wheel, you can rotate the view. When you press the Shift key and the mouse wheel, you can move the view. And when you rotate the mouse wheel, you can zoom in and out. And this is the basic navigation. And the way of this navigation results from the selected navigation style. When you move the cursor to this place and hold the cursor here, a window will appear with hints on how navigation works in this navigation style. When it comes to creating a solid based on a sketch, this is the basic operation of creating a 3D solid. And the second basic operation related to creating 3D models is an operation that allows you to remove material from a solid based on a 2D sketch, and this is the pocket operation. This operation also works on 2D sketches, and we will create another sketch for such an operation. When it comes to 2D sketches, we can create sketches on the basic planes of the coordinate system. Just like in the case of the sketch we used to create this solid, we created this sketch on the XY plane, and this is one of the three basic planes of the coordinate system. We can also create these sketches on the faces of the solid. To do this, to create a sketch on a model face, we simply select the model face, that is, left click on this face and choose to create a sketch. And now this model face is the sketch plane, and we can create a sketch on this face. And I would like to create a rectangle sketch here. I choose to draw a rectangle, and I would like this rectangle to be linked with this solid. I would like to create this rectangle in such a way that one corner of this rectangle lies on this solid line, and the other corner of the rectangle so that it lies on the other edge of the solid. In this case, this edge coincides with the x-axis, so here, as you can see, the x-axis is highlighted, and I can click here, and this corner of the rectangle has been connected with the x-axis. Now I right-click to cancel the command to draw a rectangle, but when it comes to this corner of the rectangle, this corner has not been linked with the edge of the solid, and this is because we do not have reference geometry for this solid, and in order to link the sketch with the previous stage of the 3D solid, we have to create reference geometry, and to do this we have to use the create external geometry command, and this geometry will be something that connects the sketch that we create with the previous stage of the 3D solid. To create such geometry, select this command and select the geometry on the solid. Let's select this line. Now right click to cancel this command, and here, as you can see, a line has been created, and now we can use this line to link the sketch with the solid, and I would like to place this corner of the rectangle on this line. That's why I select this point, select this line, and select the coincident constraint. And now the rectangle is linked with this solid in such a way that this edge of the rectangle is linked with this edge of the solid, and this edge of the rectangle is linked with this edge of the solid. The rectangle does not yet have this dimension defined and does not have a specific location, but when it comes to this dimension is already defined and we cannot change it. And now I would like to place this rectangle in the middle of this solid. And here we will also use the constraint, but we will do it in a slightly different way. We will use the symmetry constraint between points. We will create an auxiliary point, select drawing a point and draw a point. Right-click to cancel the point command. And now we're going to place this point symmetrically between this point and this point. So select this point, and select this point and choose the symmetry constraint. And now this point has been placed symmetrically between these two points. And that means this point is placed in the center of the solid, and now we can use the symmetry constraint to place the rectangle symmetrically relative to this point. I deselect all geometries. I left-click somewhere outside the geometries to ensure all geometries are deselected. I select this point, and choose the symmetry constraint. Now, the rectangle has been placed symmetrically relative to this point, meaning this rectangle lies in the center of the solid. When I change the dimension of this rectangle, it changes symmetrically relative to this point. I select this line, choose dimensioning, and now as this dimension, I enter here 7 millimeters. I press enter, and the sketch is already fully defined. I close the sketch, and now based on this sketch, we will remove material from this solid. We will do this using the pocket operation. Select the pocket operation, and here, as you can see in the preview, the material has been removed. The depth of the pocket is 5 millimeters. Like the pad operation, we can also change the value of this parameter. Let's set the pocket depth to 5 millimeters and click OK. As you can see, the operations. The pad operation, which is the operation through which we create a three-dimensional solid based on the two-dimensional sketch, and the pocket operation, through which we remove material from the three-dimensional solid based on the two-dimensional sketch. These are the basic operations related to creating 3D models in 3D CAD systems. These operations are very simple, but by combining these operations to create a 3D model in several steps, we can create really complex parts. Here, in this case, we have a very simple part, but nothing stops us from adding more operations here and creating additional steps. We can create a truly complex project. Other very basic operations are the operations of adding chamfers and fillets to edges. To add a chamfer or fillet to an edge, we select the edges to which we want to add this operation. If we want to select several edges, we do this with the Control key. I select these two edges and choose the chamfer operation. Here we specify the chamfer dimension, for example 5 mm, and click OK. When it comes to filleting edges, we hold down the Control key, select the edges we want to fillet, and choose the fillet operation. Here we specify the radius value, we enter 5 mm, and click OK. Regarding the operation of adding chamfers and fillets, we can also do this by selecting the face of the solid. Now I select this face and choose the chamfer operation. This way, a chamfer can be added. The chamfer will be added to all edges of the solid, and similarly it will work with filleting. We select the face, select the fillet command, and add a radius to all edges of the selected face. Sometimes you may find that the fillet or chamfer command does not work properly. This is one of FreeCAD's minor issues. We have this simple part. Let's assume that now we need to make some changes to this part. We can do this easily. When it comes to changing the main dimensions of this part, we can do this by editing the first sketch. The first sketch we created, that is, the rectangle sketch, was used in the pad operation, meaning it is simply inside that operation. To change the dimensions of this part, expand this operation, right-click on the sketch, and select Edit Sketch. Now we can change the dimensions of this sketch. Here, let's change this dimension, for example, to 70 mm. I double-click the left mouse button on the dimension we want to change and enter a new value. I double-click the left mouse button on this dimension as well, and here I will enter, for example, 50 mm. I press Enter, and I will also change the distance between the holes. I click here, double-click the left mouse button, and I will enter 35 mm. Okay, we have changed the dimensions of the sketch. We close the sketch and the changes have been applied to the model. Similarly, we can also change the values of operations to modify the length of the extrusion. Just right-click here, select Edit Pad, and we can change the extrusion value here, for example to 15 mm. Click OK, and the changes have also been applied. As for the pocket, it was also created based on a sketch, and we can edit that sketch. Double-click the left mouse button on the sketch and we can change this dimension to, for example, 15 mm. Hit Enter and close the sketch, and the changes have been applied to the solid. Regarding the depth of the pocket, double-click here with the left mouse button and we can change the depth of this pocket to, for example, 10 mm, and click OK, and the changes have been applied to the solid. This is a huge advantage of parametric 3D CAD systems because here we work on features and parameters. When creating a 3D model, we create it using parameters. Later, once we have such a model created, we have a history of 3D modeling, we have an operation tree here, and we can go back to previous operations. We can make changes to the parameters there, which means the dimensions are parameters, and we can change these parameters. Once we create a 3D model, and it turns out that something needs to be changed, we have the option. We can make modifications and corrections without having to start the 3D model from scratch. So something like that is really very convenient, and in FreeCAD, we have such capabilities. At this point in this tutorial, I would like to show you one more thing. I would like to show you how we can change the appearance of the solid. To do this, right-click on the body and select Appearance. We can choose one of the default materials here. Okay, for example, stone, and the color of the solid has been changed. Close this, but we can also simply set the color of the solid here. Right-click, select Appearance, and here we can change the color of the solid. Click this button, and here we can specify the colors of the solid. In this way, we can adapt the appearance of the solid. If you are creating 3D solids, for example for 3D printing, and you would like to export such a model to a format that is supported by slicers, that is, by the software in which we prepare the program for the 3D printer, then such a model must be saved in the appropriate format. To do this, we select what we want to export, and from the File menu, we choose Export. Next, we specify the location and file name and determine the file type in which we want to save this model. As for slicers, some slicers already use the step format. I suggest saving files in this format, as this format allows for saving files with quite a high degree of accuracy. What we create here as, for example, holes or as fillets will also be exported as holes and fillets. Another popular format supported by slicers and used in 3D printing is the STL format. This format saves solids as a mesh of triangles, meaning holes and fillets will be exported with a certain degree of accuracy. They will not be perfectly round, they will simply be formed from short segments. If we export this with quite a high degree of accuracy, it may not even be noticeable in the 3D print that the hole consists of short segments. It will simply look like a hole. If your slicer supports step files, I recommend saving files in this format. Here we specify the file name, select the file format, and click Save. We can use such settings. We can uncheck everything. We click OK, and such a file has been exported to the step format. We can use this file, for example, in a slicer, and based on this file, we can prepare a program for the 3D printer. We can use this file to collaborate with other 3D CAD systems because the step format is a universal data exchange format between CAD/CAM systems. By creating a 3D model in FreeCAD, you can save this model in the step format, and someone else who uses a different 3D CAD system can open this model and work on it. This is another huge advantage of FreeCAD and allows collaboration with other people and other 3D CAD systems. The next fundamental operation for creating 3D solids based on a 2D sketch is the operation in which we create a solid by rotating the sketch around a specified axis. Here, to create such a solid, we need a cross-section sketch of that solid. Now, I will show you this with a simple example. Select Create Sketch and let's create a sketch on the XZ plane. Choose this plane and here I will draw a rectangle. Okay? For now, without dimensioning, I close the sketch. Now, based on this sketch, I will create a solid by rotating the sketch around the global Z-axis. This is a revolution operation. Select the operation, and here in the preview, you can already see how it will look. The sketch is simply rotated around the Z-axis by 360 degrees. In this case, the vertical axis of the sketch was chosen as the axis of rotation, and in this case, this axis coincides with the base Z-axis. Here, these axes coincide, so regardless of what we choose, we will get the same solid. As you can see, we can also choose another axis around which the sketch will be rotated. Here, around the y-axis, we cannot do that because if we want to create a solid by rotating this sketch around the y-axis, no solid will be created. But if we choose, for example, the x-axis, a solid will be created. We can also select the Select Reference option here, and we can refer to, for example, an edge on the model, and the rotation of this sketch will be done relative to that edge to create a solid. Now I will return to the base Z-axis. We also have the parameter angle here, which specifies the angle by which we will rotate the sketch to create the solid. By default, it is a full angle of 360 degrees, but we can do it at a different angle, for example, 160 degrees, and then this solid will look like this. By selecting the Symmetric to Plane option, the solid will be created in such a way that the sketch will be symmetrically extruded in both directions relative to the sketch plane. And now this solid looks like this. I will return to the value of 360 degrees. This was a simple example, but I wanted to show you one more thing with this example. We will create another sketch here, also on the XZ plane. I select this plane and I will create a circle. Here, I will make sure that this circle lies in some part inside the solid. I close the sketch. At this moment, the dimensions are not important. Another fundamental operation for creating solids is removing material by rotating a sketch around a specified axis. Just like in the previous example, in the case of extrusion, we created a solid by extruding the sketch. In the case of subtracting material based on the sketch, we used the pocket operation, so in this case we have the revolution operation, which adds material by rotating the sketch around a specified axis. So we also have the equivalent of this operation that removes material by rotating a sketch around a specified axis, and this is the groove operation. Select this operation, and by default it looks like this. That material was removed by rotating this sketch around the specified axis. The specified axis is the vertical axis of the sketch. In this case, this axis also coincides with the z-axis. We can also change the value, for example, to 160 degrees, and then the groove will be created like this. Click OK, and we have a solid that was created by rotating the sketch around the specified axis. As I mentioned, this was just an example. With this simple example, I wanted to show you how this operation works. Now we will create a new example and prepare the next part. Select the parametric part here and choose to create a sketch. As the sketch plane, select the XZ plane. Now we will create a cross-section sketch of the solid, and then we will use this sketch to create a solid by rotating the sketch around a specified axis. Select the polyline drawing command and draw a polyline roughly like this. You don't need to focus on the dimensions for now, just make sure to constrain this polyline point to the x-axis. Also, constrain the next polyline point to the x-axis and then create a shape like this. Here, finish drawing the polyline so that it ends at this point, right-click to finish, and cancel the polyline drawing command. Now, select this line, and then choose the equal constraint. Next, select this line and choose the horizontal vertical constraint. Then select this line, and choose the constraint that specifies that these lines will be parallel to each other. Next, do the same with these lines. Also, do the same with these lines. Now, select this line and press the D key to specify the dimension of this line. Enter 3 mm as the dimension and press Enter. Next, select this point and specify the distance from the origin of the coordinate system. Here, enter 60 mm. Now select this point and specify this distance. Here, enter 40 mm. Now select this line and enter 40 mm as the length of this line. Then select this line and enter 40 mm as the length of this line as well. Now select this point and enter 120 mm as the dimension between these points. And now, right-click to cancel the dimensioning command. Here, in my case, this line has moved slightly, so I drag this line this way so that it is above the x-axis. I select this line, and I choose the equal constraint. We can also activate constraints by pressing the appropriate key on the keyboard. In this case, I press the E key to define that these lines are equal. The sketch is fully constrained. We have created this sketch which defines the cross-section of the solid that we will subsequently create. We close this sketch and select the revolution operation to create a solid based on this sketch. We create a solid by rotating this sketch by an angle of 360 degrees around the vertical axis of the sketch, which in this case coincides with the base z-axis. We click OK, and thus we have created this solid. As you can see, we created this solid quickly and easily. This operation is easy to apply, and the parts that we can create using this operation are solids that appear quite frequently, either in the workshop or at home. Therefore, using the operations you have learned so far, we can create many practical projects. The next operation I would like to show you is the mirror operation. We will create a new parametric part, and here we will create a sketch on the XY plane. Then, select the centered rectangle command to draw a rectangle from the center and draw a rectangle with dimensions of 100 by 70 mm. Close the sketch and add an extrude of 15 mm. Click OK and create another sketch. Select this face and choose to create a sketch. And now select again to draw a centered rectangle. Check the options rounded corners and frame here. Then place the center of the rectangle on the x-axis. Now, for the dimensions of the rectangle, enter 25 by 30 mm. OK. For the corner radius, enter 5 mm. To define the dimension of the second rectangle, we define the offset. We can specify the offset outward, in which case we enter a positive value, or we can specify the offset inward, in which case we enter a negative value. And here, enter 3 mm as the offset and press enter. In this way, we created such a rectangle. The sketch is not yet fully defined because we do not have the distance from the center of the rectangle to the origin of the coordinate systems or to other geometry defined. I will right-click to cancel the rectangle drawing command and add a dimension from the center of the rectangle to the origin of the coordinate system. Here I enter 30 mm, press enter and close the sketch. Now, based on this sketch, we will add an extrude of 10 mm and click OK. Now we will create another sketch. Select this face and choose to create a sketch. Here we will create a polygon. When it comes to drawing polygons, we have the option to draw polygons. So select the hexagon here. Place the center of the polygon on the x-axis and enter 5 mm as the radius of the circumscribed circle around this polygon. Press enter. For the dimension of the angle, enter 0 or click on the x-axis to position this polygon here. Then select the dimensioning, select the center of the polygon and specify the distance from the center of the polygon to the origin of the coordinate system. Here, enter 30 mm and hit enter. Close the sketch, and based on this sketch, let's add a pocket operation of 5 mm and click OK. Now we have two operations here. Now, with the Control key, select these two operations. Select the pad 001 operation and the pocket operation, which are the operations that created this part of the model. Now we will do something that will result in both the extrude and the pocket being generated from this side of the solid. We will do this using the mirror operation. Select this operation, and here in the preview you can already see how it will look. In the mirror operation, it is important to define the mirror plane. Here, by default, the vertical sketch axis has been selected as the sketch plane, but in this case it is easier to select the coordinate system plane as the mirror plane. I would like to add a mirror relative to the YZ plane. I simply select the base plane here. And that is how the mirror operation works. We can select one operation to mirror, or we can select several operations to mirror. As a curiosity, I will show you one more thing. We added a mirror of these two operations. Now, let's assume that I need to make some changes here. For example, I will change the length of the extrude to 15 mm. I click OK. Both this extrude and the extrude created by the mirror operation have been changed. The same will apply when editing the sketch. If I edit the sketch of this operation, change the dimension here, for example, to 20 mm. OK, I close the sketch. The changes have also been applied here. The same will work with this operation. If we change the depth of the pocket, the changes will be applied in these two places. Just like if we change the dimensions of the sketch, the changes are also applied here and here. So if you need to create symmetric parts, in some cases creating parts in such a way that we create half of that part and then add a mirror operation may be a better and faster solution. Another interesting and useful operation is the linear pattern operation. This operation is similar to the mirror operation in that we can create additional copies of a selected feature. In the case of a linear pattern, it works in such a way that we can create additional copies along a certain line, which is what the name suggests is a linear pattern. We are indeed creating a pattern based on a selected feature. We will create a sample model here. Choose Sketch Creation and create a sketch on the XY plane. Then select the rectangle tool and draw a rectangle 100 by 70 millimeters. OK, close the sketch and add an extrusion of 10 millimeters. Here we will create another sketch. Select this face, choose Sketch Creation. Now select the Draw Slot tool, place the first point of the slot here, then specify the dimension of this slot. Enter 20 millimeters here and hit enter. As for the angle dimension, type in -90 degrees so that this slot is parallel to the y-axis. Now enter 4 millimeters for the width of the slot. Right-click to cancel the slot drawing command. Select this point and press the D key to activate dimensioning. We define this dimension, enter 10 millimeters here, and we can define the second dimension. We also enter 10 millimeters here. Right-click to cancel the dimensioning. Close the sketch. Based on this sketch, we will add a pocket operation of 5 millimeters and click OK. Now I would like to have these slots placed along this solid. To do this, we select this operation and choose the linear pattern operation. Next, we define the direction. We can choose one of the available options here, with the default being the horizontal axis of the sketch. However, like with the mirror operation, it is easier to select the direction based on the base axis of the coordinate system. We can also simply choose the geometry that will define the direction of the linear pattern. In this case, I would like to prepare a linear pattern along the x-axis, so I select the x-axis. As for the number of elements, we have 2 elements. I will increase this number to 5. Let's see what happens. Here I have 5 elements, and here I have only 4 occurrences of this slot. This is because the default pattern length is 100 millimeters, and the length of our solid is also 100 millimeters. However, when it comes to the length of the pattern, it is the length measured from the first to the last feature. The length from the first to the last feature is 100 millimeters, but the center of this slot is offset by 10 millimeters from that edge. Measuring the pattern length from the center of this slot to the center of the last slot, we have 100 millimeters, so these 100 millimeters will extend beyond the solid. Therefore, here, as for the length of this pattern, I will reduce this value and pay attention to how the preview of the solid will change. We have 94. Still nothing is visible, and now something starts to appear. We have 90 and the slot is already available halfway. Next, I will reduce this value to 85. And the entire slot is now visible inside this solid. I will change the value to 80, and now it looks like this. The distance from this slot to this slot is 80 millimeters, which is the length of the pattern. We can measure this from the extreme feature of this slot to the extreme feature of this slot, or from this point to this point, or from this edge to this edge. We indeed have a distance of 80 millimeters. We can also measure it in such a way that we measure from the center of the first feature to the center of the last feature. This is how we define the length of the pattern. As I increase the number of elements, the positions of the first and last elements will not change, only the distance between the elements that are between the first and last element will change. When I add more instances, the distances between these elements will become smaller. I click OK. In this way, we created something like this, and it works similarly to the mirror operation. Now, for example, if I change the depth of the pocket, it will change the depth of all pockets, and if I change the slot sketch, the changes will also be applied to the other elements. This operation can also be useful in creating 3D models and in some cases can significantly speed up and simplify 3D modeling. The next operation in the group of operations where we create additional copies of a selected feature is the circular pattern operation. This operation creates additional copies of the selected feature around a circle, and now we will create a sample model. Choose to create a sketch and select the XY plane as the sketch plane. Next, choose to draw a circle and draw a circle with its center at the origin of the coordinate system. Enter 100 mm as the diameter of the circle. Close the sketch and add an extrusion of 10 mm. Next, select this face, choose to create a sketch and create another circle. Position the center of the circle on the y-axis, enter 10 mm as the diameter of the circle, and then select dimensioning and add the distance from the center of the circle to the origin of the coordinate system. Here, enter 40 mm and press enter. Close the sketch and based on this sketch add a pocket operation of 5 mm. Now we will create additional copies of this feature using the circular pattern. Select this operation and choose the polar pattern command. Here we specify the axis of the circular pattern, the angle at which we will perform this pattern, and the number of instances. By default, the axis perpendicular to the sketch is selected, but just like in the case of the previous operations, it is easier here to specify the axis of the pattern based on the base axes of the coordinate systems. In this case, I would like to perform the pattern relative to the base z-axis, so I choose that axis. Then, regarding the number of elements, I enter 10. And this is what it looks like. Here we can specify the angle. I can change the angle value, and then all elements will be arranged at the angle we specify here. In this case, 10 elements were arranged at an angle of 160 degrees. I will go back to the value of 360 degrees. This operation can also be useful in some cases, and in some situations can significantly ease and speed up the creation of 3D models. As for 3D modeling in FreeCAD, we can combine individual operations. In this tutorial, I showed you these operations rather one by one, simply demonstrating the selected operation as an example so as not to create too much confusion. However, when it comes to creating 3D models, as you may have noticed at the beginning, we create 3D models in stages. There is nothing stopping us from combining selected operations. In various stages we can use different operations, so just as I created something like this, I can now add another part of the solid. I can create another sketch here. I will create a rectangle, for example, in this way. Here, I will specify the dimensions of this rectangle. We will make a square with a side of 40 mm. I close the sketch, add an extrusion. Now, I will create another sketch. I also choose the XZ plane, and now I choose the command to create external geometry. I create external geometry based on this edge. I will switch to the view on the sketch plane, and here we will create something like this. I will create a line so that it lies on the y-axis. I select this point, select the circle, and choose the coincident constraint. I do the same here. Select the point, select the circle, and choose the coincident constraint. Now, I select the trim command to trim the fragment of the geometry, and we have a semi-cross section of the solid. Here we are missing a constraint. That constraint was lost, so I select this part of the circle, select this point, and choose the coincident constraint. I close the sketch and will create another part of the solid using the revolution operation. And we have another part of the solid. Now I will create another sketch. I also choose the YZ plane. And here I create reference geometry based on this edge. I will create this shape without dimensioning. Close the sketch, choose the groove operation, and we create a groove here. Now I select these two edges with the Control key and add a fillet here. As you can see, we can combine individual operations, and we can step by step create quite complex and intricate shapes using relatively simple sketches and relatively simple operations for creating 3D models. Sometimes you just need to think before creating a 3D model about how we will create such a 3D model, and then, step by step, with simple operations and simple sketches, we build the solid. Now I will show you another interesting and useful operation. We will create a preliminary sketch and an initial solid. Select the sketch creation and choose the XY plane as the sketch plane. Choose to draw a rectangle and draw a rectangle 100 by 70 millimeters. Close the sketch, add an extrusion. Now, based on this solid, we can create something like a box with walls of a specified thickness. To do this, we select the wall we want to remove and choose the thickness operation. Then specify the wall thickness. I will enter 3 millimeters here, and we can specify whether the walls should be added to the inside of the solid or if we want to add the walls to the outside of the solid. If we select the option Make Thickness Inwards, the walls will be added to the inside of the solid, and the dimensions of the solid will not be increased, meaning the outer dimensions of this box will be 100 by 70 millimeters. Click OK. And in this way, we have created something like this. Now I will press Ctrl Z. As for this operation, we can select one or several walls. With the Control key, I select these two walls and choose this operation. I specify the wall thickness, and this way we can create such a box. Then I again press Ctrl Z. And now I select this edge. I select the chamfer operation. I click OK and select this wall and this wall. I am doing this with the Control key. I choose the thickness operation, and here I specify the wall thickness. I click OK, and this way we have created such a box. When creating these types of elements, this operation can be very useful. For example, if you wanted to create some partitions here, we can do that simply by creating a sketch. I choose to create a sketch. Now I choose the reference geometry and create the reference geometry based on these lines. I switch to the section view and select to draw a rectangle. I draw a rectangle here with a width of 3 millimeters. I press Enter, and for the second dimension, I simply left click on this line. Okay, something went wrong here. I press Ctrl Z and will create that rectangle again. We can do this by entering 3 millimeters here, pressing Enter. As for the second dimension, I will click anywhere. I right-click to cancel this command. I select this point, select this line, and choose the coincident constraint. Close the sketch, I add an extrusion here, and now we specify the length of the extrusion so that it looks good. Let's do this to 15 millimeters and click OK. In this way, we have created such a partition. If you wanted to cut out, for example, a fragment of this wall, we will create a sketch on this wall. I will create reference geometry based on this edge, and I will create a rectangle, approximately something like this, without dimensioning. Close the sketch and add the pocket operation. Here we can either specify the depth value of this pocket, or we can choose one of the types. For example, let's select up to first, so that we add the pocket to the first feature. If I change the offset value here, this is how it looks. Offset 0, we have a through pocket, and the pocket is made to this face. If we change the offset here, the pocket will look like this, and the thickness of the element that remains here is exactly 1 millimeter. I will return to the offset value of 0. Click OK, and we have something like this. Here we can also add fillets. With the Control key, I select these two edges, choose fillet, and we add a radius. And this way, once again, based on several operations, we have created such a simple solid. Thank you very much for watching this tutorial. If you would like to support the development of the channel, you can make a donation. There is a link in the description of the video. This tutorial covered the basics of FreeCAD, and after working through this tutorial, you should be able to create your own 3D models. When it comes to learning 3D modeling, you need to be patient and you need to practice. Now try to create a simple 3D model yourself. Thanks again for watching, and please subscribe to this channel.